Hello, hello. It's Friday. Hello, everyone. We are getting started here. We're getting things going. We are going to be doing assembly. So over the past few streams where we've done assembly language, we've been learning assembly for the first time after so many years. Finally, we're learning assembly. We're playing with assembly. Like here, we've got this file that we were playing with a file here. Let's see, right here, ls. This is the file that we're playing with. By hello dot by main. This is what we were doing. Main.s. We were having fun with this file right here. We're having fun with this file, and so we're just messing around. We're playing with assembly. We're trying to understand it. We're learning it. We're making changes. See what works when you change some things. What breaks. What doesn't break. That's what we were working on, and it was hard and challenging. And we're finding that we can build all sorts of fun things in the data section, in the text section, which is where you would think, why does it have to be called text section? Why can't it be called like this, or like code, or like dot logic, right? Something like that. Because that's right where that's what it means. That's what dot text means. It actually means the instructions for the program. It's silly. Why does it have to be text? Oh well, but that's what we're learning, you guys. That's what we're learning. And so we did that in previous streams, but now what we're going to do instead is we're going to make a little change. We're going to go over to this HelloSilicon tutorial, and it's got all these chapters. Look at all these chapters here. We've got a bunch of chapters that we can learn from. We're going to learn from all these chapters, you guys. So we've got chapter 1 through 16. I don't know if we're going to make it through all 16 because it looks like it could get... I'm really curious. You want to see? I want to see what it looks like in the most advanced chapter. Is it going to look scary? Or is it going to look scary in the most advanced chapter? Let's jump ahead. I'm actually really curious. I'm really curious. Let's see, chapter. Let's go into the chapter 16 and look. Let's see. Okay, so there's just a few files. There's a main py, there's a main s, a make file, an odd canary.txt by odd canary. Actually, I'm kind of curious what's in this odd canary.txt. Oh, what? What is going on in here? There's some weird stuff. We don't know what this is. It looks like a bunch of assembly instructions with addresses built in. This is odd. I don't know what's going on here. I do not know. This looks like an existing running application. Okay, upper C and upper.s. Well, hold on. Why is there a .c file in here? Upper.c. What is this? This is a C file. What's going on here? This is an assembly programming. Yo, hey, how's it going? Veterisaizalazvin Murugajizin. I'm trying to say her name. Welcome into the stream. We're working on, I know this is a C file, but we're doing assembly here. We're changing our directions. Hey, what are you doing? Okay, so we're working on assembly. We have been in the past, in the previous streams, we've built, we've just been messing around with assembly. We've been trying out different things. And this is our file where we wanted to call the system to do a sleep. So we created a timer. Then we wanted to conditionally exit the loop. So basically the answer is we are working on assembly. We're learning assembly. We haven't ever done assembly so much before. Hey, Norbert, hey, happy. Welcome into the stream. Happy to have you here. We're going to learn some assembly today. This was a request. Someone was like, hey, you guys, we need to do more assembly. Dr. Uster. Hey, Dr. Usta. Learning assembly is for people who too much time and nothing to do. You're probably right. You're probably right. Here's why. Nothing to aim at. Basically, because what can you actually do with assembly? What can you actually do with it? You can't really achieve much with assembly these days because it's too much work. Norbert, you're totally right, Norbert. It's Dr. Uste. What's the point? Okay, so Norbert, how can you type with a desk that high, man? I cramp looking at this. How can you tell? How do you know? How did you know this is an unordinary desk? Norbert, how do you know this? This is an unordinary, yes, so the desk is higher up. The desk is higher up. And so I do have to make some concessions here. Def, not a bot. Oh, which language is this? This is assembly. We're learning some assembly, you guys. That's what we're doing. This code looks like my college days. I did in the labs. Yeah, this is exactly what this is. We're looking at assembly. It looks like assembly code because it is assembly code. So over the past few streams, you guys, what we've been doing is we've been learning assembly just through messing around. We understand what the registers are. We see the registers. We know what the the operators are. I said, hey, Simone, how happy to see you. How are you? Glad to have you here. Kalamata, hey, Kalamata, I really don't understand how people learn to code. I'm good with computers and technical stuff, but coding never clicked for you. That's because it doesn't click. You're right, it never clicks because there's such a vast amount of information that you have to know in order for it to click. It doesn't click until it finally does, and it takes just a lot of upfront trial and error. And it won't click right away. It takes a while. It just takes a while until it clicks, you guys. Still ARM assembly. Not Owen. Hey, Not Owen. Welcome in, Not Owen. Happy to have you here. Yep, so we're going to do ARM assembly, but today we're doing something a little bit different. We've been playing around with assembly over the past few streams, but we want to do something different this time. What do we want to do different? We're actually going to be going through some courses. So we've got these chapters that we're going to go through. So we'll start with chapter 1 and we'll go through and see how far we get today. We'll see how far we get, you guys. We're going to see all these chapters here. We've got a ton of chapters on the screen and we're going to be doing that. You struggle with Bash, so let's how clueless I can be with assembly. Haha, Norbert, yeah, no. It's Bash is its own adventure, isn't it? But we should also do a Bash stream. We should do some Bash because there's a lot of fun things you can do with Bash. Kalamata, like remembering the syntax seems impossible. It really is, but don't worry. There's actually some. We're actually going to jump into it. It's going to be really. We'll start at the beginning, you guys. We're going to start over from the very beginning in the Hello World on chapter 1. We're going to start in chapter 1. So sit back and strap in, get comfy, get cozy, you guys, because we're going to go to chapter 1 here. We're going to go to chapter 1, and we're just going to let it happen. So there's only 2 files. We don't have to worry too much about this, you guys. Hey, Turan Kumar. Hey, how's it going, Turan Kumar? Welcome in. Thank you. Happy to have you here in the stream. We're going to be doing some easy assembly today. The plan is some easy assembly. We're going to use Vim. With Vim, yeah, you're right, Not Owen. With Vim, it may literally never click for you. Oh, that's also a really good point. It depends on the tools that you're using. It really does. It depends on the tools. Sanskar, hey, how's it going? OG content, love from India, brother. Thank you. Happy to have you here. Happy to have you, everyone here. We're going to be sitting back. We're going to have a cozy Friday stream. We're going to be looking at assembly language, and we're going to start with, it's called, what was it called? LS here, ls dot dot. It's called Hello something. I needed PWD is what I need. PWD. Here we go. It's called HelloSilicon. We're going to do the HelloSilicon tutorial. This is a specific ARM assembly for ARM, basically ARM architecture. Tehran, Stephen, hey, even Stephen, who's been programming from literally longer than I have been breathing. I'm 21, FYI. Mistakes for CH and C. Yeah, you saw that. I know, you saw that. You're paying attention, aren't you? You are paying attention. I did type the wrong CH for CD. Yeah, you're totally right. You saw that. These little easy mistakes. Yep. Even after all these years, you still have keystroke slip-ups, you guys. You still make mistakes, and you still have things to learn. It's not over. It's never done. As many years as you're on in the job, you still have more to learn. It's because things keep changing. Things continue to change. They're always different. They're never the same. And so you have to keep going. FF Delight. Hey, how's it going, FF Delight? Hello, YouTube recommended this while scrolling. Really? That's amazing. Welcome in. We're going to be learning some assembly today, and we're going to start with chapter 1. In previous streams, it says assembly day 6 up here. You can see assembly day 6 right up there. You can see it, assembly day 6. But we've been playing around with assembly. We're going to do a more structured learning now. I think we're going to start with chapter 1, you guys. So sit back. We've got chapter 1 here. We've got a couple of files. Thank you for the likes, you guys. Appreciate it. We're going to have a cozy Friday stream learning some assembly today. We're going to learn Hello World, and we're going to start with chapter 1. There's also a nice make file in here. So all we have to do, I believe, is to type make, and it builds for us. Let's actually see if that works. Oh, it worked. Wait, did it or did it fail? Did it work? No, it built a binary for us. Okay. Ashford, hey, welcome in, Ashford. It's good to see you. Happy to have you here on the stream. We are going to be doing some assembly, and we're going to be doing it in a more structured pattern this time around. Hey, hit the fan. Hello, hit the fan. How's it going? I've been trying to get into reverse engineering. Oh, we should get a disassembler on here. Disassembler. I know we can get a disassembler here, and I think that would be a lot of fun. We should probably do that at some point. Let me add that to our list of things to do. All right, so future stream idea. Thank you guys for the likes. How do we say disassembly? Reverse engineering. Actually, let's just type reverse engineering. Reverse engineering. There. Now we don't have to spell disassembly. Future stream idea. We'll do reverse TIL. There you go. You got it. Is also LS. Oh wait, what? Wait. I don't know what that means. Oh, you've been trying. Okay. Thanks for the YouTube algo. Absolutely. Thanks to YouTube algo. Awesome. Subscribe. Thank you. That's great to hear. We will be doing some. Oh, you mean LS-A, LA? Yes. LS-AL. Yep. There you go. I also have L. I've aliased L, just the letter L, because I like it. And then I think LL as well. Nope, just kidding. Just L. Just L. Yeah. So LS-LSRTAH is my favorite combination of add-ons, or what do you call arguments? This is my favorite arguments for the ls command right here, you guys. LSARTAH. These are the best right here. Boom, check it out. And it looks like this. It gives you a whole bunch. No, that's def. L's command is the same as typing ls-l. Oh, is it? Is it really? L is not aliased? Are you serious? No, it is. Oh, thank you. Thank you for subscribing. Appreciate it. Happy to have you here as a subscriber. We are going to be doing a lot of hard mode stuff here in this stream. The plan is hard mode stuff. We want to learn assembly. We're going to learn artificial intelligence. We're going to learn reverse engineering. We're going to learn some of the crazy hard stuff. Encryption. We're going to learn some encryption, you guys. That's going to be the plan. We've got a lot of streams coming up here. On the weekdays, we'll stream on the weekdays for an hour. Since when you are learning this? Oh, programming with Anas. Hey, programming. Welcome into the stream. Happy to have you here. Since when are you learning this? Okay. Right now. We're going to learn right now. Let's open up the file, you guys. All right. So let's open up the hello world.s file, which means assembly. S for assembly. Why can't it be .as? AS sounds better. Why did they standardize on the word and the letter S? I think it makes the most sense to be assembly. Okay, so this assembler program prints hello world, standard out. Cromer, hey, good to see you, Cromer. Happy to have you here. Happy Friday. We're going to be doing some assembly, but we're going to do it in a structured way going forward. We were playing around with it before, doing all sorts of things before. Remember this from previous streams? Well, we're in the previous stream, we did some of these things. This time going forward, we're going to do it in a structured way. So we have this hello world, HelloSilicon, CD HelloSilicon, and it's got all of these chapters in it. We're going to start with chapter 1. Try sudo rm-rf /. Yeah, thank you, Lauren. Let's delete everything on the entire hard disk. Why don't we? let's delete it all. Delete everything. The stream will crash. All of it will be gone. Oh, that would be problematic, just a little bit problematic if we sudo rm-rf /. Yeah, just get rid of the entire root mount. Get rid of root. Yeah, tomorrow and the day after tomorrow is a holiday. Cromer, is it? That's really cool. Tomorrow and the day after tomorrow is a holiday? Nice. Yeah, so that's for me as well. So on the weekend, we rest on the weekend, but on the weekdays, we stream. So every weekday we stream, you guys. That's the plan. Free from company politics and toxicity. There you go. Nice. Hit the fan. Yep. You gotta be careful with recommendations on the internet. So much that we going on in here. Okay, so let's start here. So assembler programming. Let's print hello world to standard output. Standard output. Is that a yes? Oh, Stuart Dahaman. Stuart Dahaman. Hey, how's it going? Welcome into the stream. Is that a yes? I don't know. It could be. It might be. In some days, it is a yes. Turan, hey, yeah, we make it like a game where if it PRG fails to compile, it executes the sudo command. That's a roulette game. Okay, so there's high stakes. That's a high stakes compilation, Turan. It's a high stakes. If you do not succeed at compiling your program and it fails, then sudo rm-rf the entire everything. You crash the whole computer. It's gone forever. High stakes programming, you guys. Maybe we should do that. We should do high stakes. Oh wait, future stream ID. Future stream idea. Here we go. High stakes programming, right? So we got to put something up. Something will happen if you fail. Something happens if we fail. That sounds like a good idea. That sounds like a really good idea. Have you thought about going to therapy to get rid of some childish behaviors that hold you back in life? Oh, Lauren, actually, yes. I mean, I think a lot of people might have attempted that conversation before. That is a possibility. Good question. Oh, programming with ANS? Programming. I started following you 4 days ago and I really like your stuff. Oh, thank you. Appreciate it. That's so cool to hear. This feedback is really valuable. I appreciate it. So we'll continue to do these things. Echo the OpenAI API key. Oh, good idea, Turan. Good idea. Nice. Okay. That's really good steaks. That is really great steak. Really good idea. That's a really good idea. Okay, so that's what we'll do. You guys, that's what we'll do. We could have, if the program fails, we'll echo the open API key. I like that one. Because that is an environmental variable. It's there. Bro, still I'm getting the goosebumps when I see you. Really, Cromer? That's so cool. You own a company, dude? I do. Yeah, you're right. This fascinates me. You got it. Yeah, we're succeeding. We've succeeded at life, and I'm excited to share that with you guys. Any questions you have, just let me know. We can talk it through, and I can help you. I can help you along your way. Man, why, dude? I know. I think it's going to be a great idea. I think it'll be a lot of fun. Alex Fex 2004. You came up with the courses about assembly language? Yeah, I found some courses. So we're going to be doing these courses here. There's 16 chapters, you guys. There's 16 chapters. You got it. I like it. Great steaks. Yeah, shout out. It's a great steak. I like that. It's a really good idea. I think we'll have to do that. Lauren, you are not a nice person. We can keep it nice. We can definitely keep it nice. So let's see here. Childish behavior is what makes life easier and not feel sucky at adult life. It is, Casper. Casper, you bring up a really good point, Casper. What makes you happy in life is actually what's really important. And it could be a childish behavior. Often, like, I still play video games, and video games are great. And then you can have a lot of fun with your video games and other things. And then, what's the most childish thing that there is in the world that can exist? I think is something called pretending, right? You can pretend or imagine, and you can do those pretending things. And sometimes that's fun. Why can't we still pretend? Like, I know we're adults now and we've got responsibilities and we don't have time for pretending anymore. But hey, we're going to do some assembly code now. That's what we're going to do. We're going to jump into assembly. Okay, let's do it. So, assembler, the register is X0 to X2 parameters in the Unix system calls. Okay, so these are going to be stored these are going to be used, they're going to be reserved as parameters for Unix system calls, which, of course, can be on Mac, could be on Linux. It could be on different things. It's a lot of different things that we could be on. Hassam, am I inside a matrix? I don't know what these codes are. I know it looks like the matrix, doesn't it? It really does look like the matrix. In previous streams, it's like, oh, whoa, what's going on? What's happening now? What are we looking at? We're looking at assembly, you guys. Cromer, is it possible to switch companies after joining for 4 months ago? Is this possible to switch company after yeah, it is. You totally could. I mean, it becomes a weird mark on your resume. And that's definitely a question mark, right? Because you're like, I'm concerned, Cromer. I'm concerned. Why was it only 4 months that you were there? Why were you only there for 4 months? I'm concerned, Cromer. Why did you do that? What's going on here, you guys? Not on. I'm ready to pretend you'll make something useful with assembly. Okay, let's do that. That's what we're pretending now. We're in pretend mode. We're going back to childhood. And we're going to pretend we're going to make something useful with assembly. Thank you for not on. Thank you. All right. So X16 is going to be a register for a mock system called function number. Oh, and mocks, I don't know what that means. What is mock? MACH means, what is that? Unix system context. Oh, architecture. Architecture. Is that what architecture is? Multi-architecture. Multi-architecture. See, you guys, we're figuring it out. Oh, Hassam, a question mark? Nah, a big Hulk, like a question mark on a resume after 4 months? Yeah, it is. It's like a ginormous question mark. A ton, like only 4 months. 4 months, right? 4 months. Let's see if I can spell this. Question mark, exclamation point, right? And repeated over and over and over. What's this 4 months? What's going on? Yeah, it's like this, like saying a little bit more here, and then Seach, and then Seach. Yeah, this. Wait, 1 second. Yeah, that's why I was thinking to stay a little bit more. Okay, cool. And then Seach. Yeah, okay. Sounds good. Oh, what? Oh, of Vogue member 3000 Ultra. Your name is amazing. Check out your name. All right. What is assembler for exits? What is assembler for exits? Assembler for exits. Okay, so right here we have actually got that. I'm pretty sure this is not what you're asking, but this is the answer that I think. So you argument 0, you put it in your register, you put 0 in a register, so it's just literally the number 0. And then you have a system call and service, and then you have for the return code. In X16, you're going to say number 1, which is just the literal number 1, and that's the system call to terminate the program. And then you say CSV to terminate, right? Which then puts X0 and X16, and then it knows the, apparently, I don't know how it knows what to move. How does it know to move, you guys? I don't know. So Steven, Turan, okay, so we've got a question. Turan, yo, Steven, did you read the paper and coding machine? Oh, right. I didn't. I didn't read those, but I have it in my phone, and it's like sitting there ready to go. I didn't read them. That I shared with you last week on Discord meetup. I didn't read it, Taran. I didn't read it. I feel bad for not reading it, and you just reminded me that I didn't read it. I want to. I have an ambition to read it, but I haven't read it. Is the answer. Sorry about that. How was it? I didn't read it. Ooh, the artist Rue, thank you. Good luck. Appreciate it. Safat. Hey, Safat, Rowan. Bro, do you know about the Nyark Linux? Like Nyancat Linux? Nyancat Linux? Is there such a thing? Is there a Nyancat Linux? Hold on, we have to look this up, you guys. We have to look this up. NYARCH-Linux. Thank you for likes, you guys. Nyark Linux is a Linux distribution based on Arch Linux that aims to give the best Linux experience to weebs. Oh, no way, you're kidding. I like it. This is no crazy. You're kidding. This exists. This is real. You guys, Cat Curl Downloader, Nyark Assistant. Okay, so, all right. Okay, it's for anime. Linux distro for anime lovers. Did you know that this existed? Did you guys know that this existed? This is a real thing. Look, you can download it right here. The perfect Linux distro for degenerate weebs. I had no idea there was such a thing, you guys. That's crazy. Who would have ever think? Vogue member, thanks. Yeah, no problem. Cromer, guys, he knows everything. He just pretended that he doesn't know how to code in assembly. He just, expletive company. Yep, I do. This is true. You've got it. You've got the answer. I could be doing anything right now, but I'm programming assembly with you guys. I do know a little bit of assembly, but not a lot. We're going to be learning together. We're learning together, you guys. I'm the guy who literally failed in math, and it sees like this live. I don't even know what I'm seeing. Hassam, yeah. We've got a lot of stuff that's going on here. Safat, yeah, I know. I didn't know that existed. It's crazy. Subject AI. Good to see you again. Hoping all good. Everything's good. We are good, you guys. We're going to be doing assembly. We're learning today from a guide now. It's called HelloSilicon. It's called HelloSilicon, and you can search this. It's a GitHub repository that has 16 chapters that gets you up to speed on ARM64 Apple Silicon assembly, and that's what we're doing. That's what we're doing, you guys. All right, how much time do you need to learn and understand AI? A lot. Programming, you need a lot. You need a lot of time. It took me years. It took me years to really figure it out. But you know what? It's a lot easier now because I started back in 2014-ish, 2013 with AI. And there wasn't a lot of learning materials, and there wasn't a lot of accelerators, and NVIDIA only had just come out with CUDA back then. So CUDA was just on the market. And so there was a challenge there. There's a lot of things to learn. How much, so that's how much you need. The Nyark Linux hero page was something else. I know, wasn't it? Isn't that crazy? It's crazy. I didn't even know that this was a thing. Of course the internet had to come up with this, right, you guys? Of course the internet had to come up with a Linux distro for degenerate weebs. Like, who would ever thought, you know? I didn't think that was crazy. Hola, amigo. Happy. Hey, welcome in. Happy to see you. Good to have you, bro. I'm wondering who made that Linux distro. Me too. Who made this distro? Who made this distro? Who made this? All right, let's find out. Who made this distro? Linux. Who made it? Who made it? New York Linux was developed by a user or a community of users, not a single creator, you guys, as it is a custom distro based on Arch Linux and EasyArch, focusing on weeb culture. Its origin can be traced to this GitHub repo. So who's the original? Oh, we don't know. It became an organization. So it could be Italy, I guess. Italy. All right. So we know someone in Italy started it. Somebody in Italy, you guys. It's somewhere in Italy. Thank you, Italy. Thank you so much, Italy, for bringing this to us. Who would ever thought, you guys? It is crazy. Reminds me of Rebecca Black Linux. Oh, is that another thing? Wait, are we gonna? Hold on. Let me open that up in a different window because that could be like a problem. Hold on. Rebecca Black Linux. What is this? What is this? What is it? Okay, here we go. Here we go, you guys. Is a Debian-based live distribution which can be used to run Wayland desktop sessions. What? Wait, that sounds okay, right? That doesn't sound like a problem. Oh, Rebecca Black OS. All right. This one, okay. I don't know what I would use it for, but it definitely is interesting that it reminded you of that. That's very interesting. Very interesting indeed. Okay. LO, they don't even have donations page. Really, Tower? They don't even have a donations page. It's just up for free as much as you want. Have as much weeb content in your links as you want. Are you using Tmux or Screen? Chromer, this is Screen. This is Screen. This is GNU Screen. So we are using GNU Screen. This is GNU Screen. Yeah, GNU Screen. So you can see here, we've got our GNU Screen, different tabs that I need to name. I need to name my tabs here. Let me do this. Let me name this to HTOP. There we go. And then let's see, what's the next one? This will be our, this is our tutorial. So let's name this tutorial window. This is our tutorial window. Okay. And then we can go over here and then we call this one our OG version, right? That's where we used to play. And then we don't need to name the other ones. We don't need to name the other ones, you guys. We don't need to name the other ones. Let's close that. Let's go over here. Okay. Let's go back to our HTOP. We'll go back to HTOP. There we go. 0. Thank you. Okay. Thank you for the likes, you guys. Appreciate it. Everyone can learn easily, but coming from a solution with solutions, and particularly, is the thing that takes really long time and patience. Yeah. You're totally right, Hassan. It takes a lot of effort and time, but it's worth it. It pays off and it's a lot of fun. Although, you know what? Guess what, you guys? Guess what? AI, it's making it way easier to build all these things without having to learn a whole bunch. What does that mean for us as humans going forward with our knowledge? Do we need to know as much? The AI and the computer knows it all, and it can write programs for us going forward. Goggy Smoggy. Hey, Goggy Smoggy. Hey there. Hey, Steven. There is also a Justin Bieber Linux distro. Are you kidding me? Are you kidding me? Thank you for the likes, you guys. I appreciate it. Is there really a Justin Bieber Linux distro? Are you kidding me? Justin Bieber Linux distro. Is it? Is there really? There is. Okay. Still using Windows? Stop being and use Justin Bieber Linux. Okay. There you go. Who would have ever thought? What other kinds of weird Linux distros are out there, you guys? What other kinds of Linux distros are there? I didn't know. What editor are you using? Chromer. Oh, so the editor we are using is, this is Vim. We are using Vim. So Vim, here you go. We are using Vim improved version 9.1.754. 0.754, you guys. Using Vim. We're using Vim. Vim improved. Vi, but improved, you guys. Subject of AI. In early college days, every time you thought of learning C and C++, my mind would just short. It would shout, cancel, and cancel plus. Thank you for the likes. Thank you for the likes. Cancel, and cancel plus plus. Prompt fail. Hey man, how's it going? Welcome into the stream. We're going to learn some assembly today. We're getting cozy. Thank you for the likes, you guys. We're learning some assembly and answering your questions is what we're doing. And that's the plan. Chromer, I'm working on an agentic AI threat simulation from the last 4 months. That's right. You were mentioning this previously. And you can manipulate AI chat robots. Oh, that's so cool. Thank you for the likes, guys. Appreciate it. So you can see here on the screen all the like crazy icons that are showing up here. They're floating up on the screen. And so you're working on it, and I can manipulate AI chats with prompts you created, red teaming this threat simulator, which generates dynamic prompts. Really, Chromer. Okay. So you're going big on this, aren't you? Thank you for the likes, you guys. Appreciate it. I like to see those floating icons there. Hassam, I learned corporate branding since my college time as a hobby. Oh, wait, really? Corporate branding? That's like a whole thing, isn't it? Well, doing it fun for after 10 years, I can say I'm very good at it and earning a good amount. Really? That's a really good job, Hassam. Good job. Just because I was learning something with fun touch. There you go. I think that's really important. Hey, Steven, Jack Keeble, welcome in. Good to see you. Hit the fan. Cool, Cromer. Jack Keeble, happy to have you in. Thank you for all the likes, you guys. Appreciate it. It helps the stream a lot. So yeah, Sam, that's actually a really good point. Really critical. Want to do the things in life that are fun. They're fun for you. Got to do the things that are fun, and you will learn them, and it goes for it. On the example, I really like to learn to program. We're learning to program today, you guys. Goggy Smoggy, there are thousands of distros. I am already using Linux as a primary OS. You are? That's really cool for the 15 years. So feel free to ask questions about Linux distros. Are awesome. Very cool. That's awesome. That's great to hear. We are a fan of Linux, you guys. We love Linux. We love our Unix systems here. We love Unix systems. Okay, here we go, you guys. We're going to do it. All right, so let's do the start. We've got to start. This is an interesting format. This is very interesting. All right, so start. You can name this whatever you want, but it depends on your makefile or however you build it, right? So we learned this in previous streams. So /_start. I think you can change this. So eStart, we can call this eWeeb. Let's do that. Let's change it to Weeb. Let's do it, and let's make sure this works. Weeb. I'm pretty sure that'll work, you guys. Jack Keeble, what are we working on today in assembly? Okay, so we've got this HelloSilicon right here. We've got this HelloSilicon you can see here at the bottom of the screen. HelloSilicon, it is a tutorial that is a GitHub repo that has 16 chapters. We've been playing around with assembly for the past few streams, and today what we're going to do is we're going to learn more methodically using some pre-existing materials. So we're going to start in chapter 1. We're going to start over from the beginning, and we're going to get cozy, you guys. We're going to get cozy. We're going to get cozy. All right, let's see here. Let's see, and let's go this. Let's go CD to. Let's go to chapter 1 or 01. Thank you for likes, you guys. Here we go. Here we go. Not KSLS. Here we go. Okay, so I believe we should just be able to say make, and it should still work. Oh no, it doesn't like weep. I thought that would work. Didn't that work? Couldn't we get that to work? Hold on. Start. It doesn't exist here. Because I didn't say global. Okay, so gloweeb. Here we go. All right. Now it should work, right? Now it should work. I think it should work this time. So the hilarious thing is first reject to create harmful code, but it can inject prompts such that it fails for, oh really? So with your, okay. It fails for it and it generates harmful codes, basically red teaming framework has reasoning agents. That's a really good idea. That's really valuable. Cromer, what you're doing, if you ever have an opportunity to allow to share it, I will be more than happy to walk through it on stream. I think that would be a lot of fun. Would be entertained to give it a shot. Would be entertained by far. Okay, let's see here. Let's go in. Let's see. Now is it going to make, you guys? Is it going to make? See, we can do it. We called it Weeb this time. We're learning, you guys. We're learning. So you have the entry point. You need the -E entry point right here. So this is important. So you can name your entry point whatever you want it to be. It could be whatever you want, but your entry point is right here. And you have to say global, and you have to say prompt fail. Anyone struggled with the point of giving up? Yes, it is. You get to the point. It's called burnout. The point of giving up is called burnout, you guys. Burnout with Claude. And then suddenly, at the final moment, Claude just whips out a result that is better than expected. I've distilled that. You've distilled that result as a prompt. Did you? Wait, prompt fail. What do you mean? Actually, that's a really good point. Prompt fail. That's really good. I'm really curious about that prompt fail. Because yeah, definitely hit that moment where Claude, you get used to it after a while. And then suddenly Claude is, not doing what you want, but then it works. It works all of a sudden, but you distilled it as a prompt. I'm kind of curious about that. Abdul, hey Abdul, welcome in. Happy to have you here. We're going to do assembly today. We're doing assembly and we're learning from a tutorial today. Is that the Easy 68K compiler? Oh, actually, I don't think so. So we're not using a compiler. We are using an assembler and we're using a linker because we're only writing assembly. We don't need a compiler, you guys, because a compiler will compile to assembly and then an assembler assembles assembly code to machine code, and then you use a linker to take that machine code and then link it up to all the operating system things. Whatever the linker does. That's what it is. Basically, Stephen, I made a project It's not personal projects, so I can't. Oh, Chromer. Oh no. Okay, that's okay. That's understandable. But I can show my 2 projects. One of them takes Insta Reel. Oh, it takes an Insta Reel or post, cartoonizes it, and it posts it on your account. That's a really good idea. It's like a derivative content, and it could be even more entertaining, and you could probably garner a good amount of audience that way. That's a really good idea, Chromer. Dang, you guys you're smart. You guys are smart. Abdul, okay, great. Glad to join. Okay, cool. That's great to hear. All right, so we're learning assembly, you guys. Okay, so we just got ourselves here. So we just updated the make file. I like to do this. I know there's indentation, but I like it like this. Like we know here. Let's do a little bit of indentation, not like a bunch of indentation. Like that's way too much indentation for me. I like just a smidge of indentation like this, at least that much. 4. Mohammed, hey Mohammed, welcome in. Happy to have you here. We're doing some assembly. We're learning from a tutorial this time. Thank you for your likes, you guys. Chromer's second personal project is a karaoke project. Oh, it's a karaoke. Karaoke, you guys, which takes song and then you use demux. What is demux? A separate music source. Oh, in vocal and background music. And then you used Whisper to transcribe it and print it to a video. Whoa. Chromer, you're a multimedia person. You are a person who knows how to make these AIs and you can command them to your media whim. You're building something kind of impressive. There's a lot of opportunity in business in what you're doing, Chromer. That is really cool. All right, jumping back into this. All right, so we've got register 1. Basically, it says set x1, which is usually used for arguments and parameters, to number 1, which is going to be standard out because we're going to call service. We're going to call service, and this is x0 is one of the arguments for service to represent what we're going to call in the service. So standard out is a static number. It's a static enum, basically saying that we're going to be calling standard out. And then x1 is going to be I believe, let's see here, string to print, and then length of our string. Okay, 13 is the length. How do we know it's 13? We got to check this out, guys. We got to check this out. Prompt fail. Okay, I got it to anchor to the deep thought process immediately, and then started testing it across other models, getting awesome results and reducing errors by 90%. That's a lot. Prompt fail. Good job. That's a huge win. Very nice to hear that. Mohammed, building your portfolio website on the side while watching this live stream. Cool. That's a great way to do it. Absolutely. You can be productive in multiple ways at the same time. Chromer, fun thing, I used Kaggle's scheduler, which run my codes every day at 5 a.m. That's really cool. Kaggle. I thought Kaggle was just for data. I didn't know that Kaggle also had a scheduler. That's really smart. Maybe it's a different kind of scheduler, because I'm thinking like Kaggle, the data set for AI AI training and AI models. Yeah, that's pretty smart. I didn't know you could do that. Thank you for your likes, you guys. Appreciate it. Here we go. Okay, so move 1, x1 is going to be an argument for standard out. So this is the service command we're going to call. What's x16 here? What's x16? Unix write system call. See, I'm not familiar. I don't know what this is. So what is going on? X16 multiple architecture system call function number, which means it's a Unix and thank you for the likes, you guys. Appreciate it. You can see those hearts pop up there on the screen. Okay, Kaggle is just like Google Colab. Oh, is it? Okay, which we can use to train the models, which has free GPUs as well, does it? It gives you free GPUs? That's so generous. That's very generous of them, you guys. That's so generous that they do that. GPUs, they are worth a lot of money these days. They're very expensive, very expensive. Okay, let's see here. So we've got hello world, and then this is one of our variables. Oh, what? You can define variables anywhere you want. Thank you for the likes, you guys. Appreciate it. You can define variables anywhere. Are you kidding me? I thought it had to be like up here in the data section, right? I didn't know you could do that. Hold on, you guys. Hold on. Let's see here. Make. Can it work? That works like that. What about this data? Can you do that? What about this? Does that work too? That works too. What's going on here, you guys? I was lied to. I feel like I've been betrayed. I didn't know that you didn't even need this. You don't even need this, you guys. This is not necessary at all. It's crazy. Chiru, Royal, hey, welcome in. Welcome to the stream. Happy to have you here. We're currently having a good, relaxing time with some assembly. We're doing tutorials. We're walking through the tutorial. We're learning about assembly. That's the plan for today. We're in chapter 1, the very beginning. We're doing Hello World. But I feel like, so we don't even need this data here. We can get rid of it. Let's get rid of that data. We can put this Hello World wherever we want. You can even put it at the bottom, you guys. You can put it right here. Look. Ooh, whoop, no, not that. Here we go. Let's bring that back. Here we go. And then we'll go like this. Okay. See, you can have it right here at the bottom of the screen this whole time. Did you know you could do that? Did you know? I mean, I kind of like it better at the top. It feels better at the top. But I think, right? Isn't that weird, you guys? I think it's weird. All right, so, and that still builds. It still builds. It works fine. So let's run this. Let's run this application, you guys. Bro, that was really good welcoming me. Oh, it was cool. Chidu Royal, welcome. Happy to have you here. We're here. We're enjoying ourselves with some assembly, and we're gonna take it easy on this Friday. We're just sitting back and learning through some tutorials. The tutorials are from, what is it? PWD. It is the HelloSilicon tutorials for assembly, you guys. That's what we're working on today. We're starting with chapter 1. Cromer, hey, what's good Copilot model for in your view, Claude or GPT-5? They're both, I don't know, but you know what? I've been using code I think I don't even know what I'm using, to be honest. I don't know. How can you tell what, because I am using Copilot here. So I'm using Copilot. Let's see here. Copilot. Let's see, ready. Copilot ready. I wonder, maybe you can do a question mark. So Copilot, question mark, unknown command. Maybe we need to say help. Okay, here we go. What model? \C. I don't see it. Actually, I don't know. I don't know if it's GPT-5 or GPT is probably one of the GPTs that I'm using with Copilot right now. It's probably for the answer. It could be any of those. It could be Quinn 3, GPT-5. I'm not sure. I think those are really good ones. Prompt fail. Good recommendation. Gagi Schmoggy, the Academy lied to me about .data. My degree was a lie. It was. It's a lie. You guys, it's a lie. This whole time. We didn't even need it. It's not required this whole time. Who would have ever thought? It's not required. They got it wrong, you guys. It's not a necessity. You don't need to say .data. You don't. It doesn't do anything. It doesn't do anything. See? Watch. Make. Oh, hold on. Did I do something? What? Hold on. Is it okay. It's a problem if you put it here, but if you put it up at the top, it doesn't matter. Let's see. Can we say .data like this? Like that? What happens if we do that? Is it going to be fine? It's fine if you put it up there, but you don't need it. It's not necessary. It's not required. This whole time, you guys, we thought it was required. We thought it was a requirement. GLM 4.5 is brilliant for a fraction of the cost. Oh, is it? GLM 4.5 is a way better. Oh, GPT-4.1, that's the one that's defaults for me in Copilot. Jack Keeble, yeah, I think I'm probably still, like you, Jack Keeble, still on 4.1 in my Copilot. I need to upgrade it. At some point, but it does fine. It is what I needed to do for now. Cromer, we are using GitHub Copilot in our company, and it has lots of models like GPT-5, Claude, all versions, GPT, all versions, Gemini, yep. Yeah, the Copilot here that I've got running, Pilot, I don't know what model I'm running, but I know I could change it. I don't know how to tell which version I'm running either, but I'll have to modify. I know there's a way to set it. So it's whatever the default is. That's what I'm currently using, and it does a good job. At Cromer, Cromer. Yep, because that's a lot. That's a lot of options. So we don't need data. It's gone. There you guys. We're learning our things, you guys. Okay. So move 2 is going to be x2 is going to be the length. X2 is the length of our string, x2, and it's hard-coded to 13. Number 13, it just means literally the number 13, which is going to be the length of Hello World. See, let's actually count it. Here we go. Let's count it. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's 13 characters, and this \n counts as one character. Even though it's 2 characters on the screen, it only counts as one character, you guys, right here. One character. This \n. So it's 13 characters here. You see, 13 characters. Wow, who would ever thought? Okay, so the length of our string. There we go. Are there tabs? There's tabs in here, aren't there? That's what's going on. It's tabs. There's tabs in here. That's crazy. Who uses tabs anymore? Do you guys use actual tabs or spaces? Tabs or spaces? Obviously, the answer is spaces because it works universally in all text editors. Spaces are guaranteed to have the same indentation no matter how many characters are involved. So spaces are really, really useful. If you're using tab characters, yeah, it does save on keys or characters in your file, but who cares? Who cares about that? Because it's not like it's a lot. It's a very small amount of characters you're saving. Cromer, tell us the best thing that happened or any best incident in your life. Oh, okay. Tell us the best thing that happened or any best incident in your life. Ooh, that's a good one. What's that? A lot of things are coming through my mind, but I need to figure out which one's like a really good one to mention. What's a really good one to mention? Let's see. So, I like it. Maybe probably when I raised the, okay, here, probably becoming CTO of PubNub. Yeah, there you go. Here, okay, so let's go. So, yep, wait, don't click the download button. We don't want to click the download button. Let's get rid of that. Pubnub.com, here we go. So, let's go maybe Crunchbase, PubNub. Here we go. All right, here's a good one. Actually, I think this is a really good one. We could do that. Yes, we are. We got the VPN turned on. But we're still doing fine on our stream. Okay, we're still doing good here. Let's see. Is there a button here? Let's get rid of this. Let's see here. Is there? Oh, we're Series E. Oh, there you go. But can we see the previous? Okay, so it's not even showing. So the one that it's not that we can't see. Let's hold on. Let's see if we can get rid of this here, you guys. Let's answer Cromer's question. I think it's a really good question. When I raised Series A was probably a really good one. I think that sounds like a really good one. Can we delete this? Inspect that little hover thing here. Can we delete that? Is this here? Let's see. Can we delete that? Get rid of that? Oh, let's see if there's, let me delete that. Okay. It's still blurry. Inspect element. Maybe we can deblur it. Can we deblur it? Maybe there's a way to deblur it. I don't know. But what we can do is we can just copy and paste it. So what's going on here? We'll do this, copy and paste. Oh, wait. Let's see. We got a few more. Cromer, is that an enterprise deployment and how is it securely integrated into your DevOps? Just curious about how AI is being developed into companies. Oh, that's a really good question, Jack Keeble. Really good question. Goggy Smoggy, tabs are spaces, but you have to make a config in that .vimrc file. Yep. I like spaces. I use that. So probably when I raised Series A, so the one you can't see here on the screen, the one that you cannot see because it's blurred out in Crunchbase. That's the one. But I probably could log in and reveal it. Here we go. Let's see if that works. Okay, here. Nope, just kidding. Let's see next. Nope, I don't want to select anything. Other, go away. Okay, free trial, go. Let's see. Okay, it's still not showing up. Anyway, probably when I raise Series A, I think that would probably be the best question or answer because it's really exciting. Because here's the deal. Here's what happened. They gave the piece of paper that said, "Here, we'll give you a bunch of money." And I was driving home and thinking whether I wanted to sign it or not. But you have to decide whether you're signing it because you're making a big choice there because you're selling equity in your company for funding. Right. And so it's scary. It's scary. It's a scary prospect. And so you call people and you ask them, hey, is it a good idea? And you know what I did? I didn't sign it. You guys. I didn't sign it. And then we kept working together and the numbers kept going up. Isn't that crazy? I think that's a pretty good one. So driving home, had the piece of paper in my hand and I didn't sign it. You guys. All right, here we go. Let's get back to some assembly. Cromer, Jack, actually, okay, so Cromer's answering Jack's question. Actually, I'm into research and dev. Projects does RFPs and POCs, proof of concepts. Agents and tools are hosted on MCP server for high-level security. In my case, we have on MCP and into AI security nowadays. Oh, that's actually pretty smart. Yeah, you got to be careful with those MCP servers and running unknown code, just running random code on your machine. Of course, we're all kind of used to doing it because what else are we doing? This code that we're currently running is, I'm not going to read the entire operating system code. I don't know what's going on there. You have to trust people at some point. You're really good, bro. Cool. Thank you, Chitu. Thank you. Appreciate it. Chitu Royal. Awesome. Divine Bulls. Hey, Divine Bulls, how's it going? Bro, I'm a cybersecurity engineer and my HR is grinding up my brain. Any suggestion? What should I do? Wait, okay, that sounds like a problem. Divine Bulls? You seem to be in a problem situation right now, don't you? You seem to be in a problem situation. What do you want to do? What do you feel like you want to do? I think that's actually a really good question. You have to think about your feelings. What are your instincts? Your instincts is really just another way to say, what are you feeling like you want to do? Do you want to take action? It sounds like you want to take action. It sounds like you want to do something about it. Cromer, we are building a framework which will stop malicious users which are tied into injection prompts or misuse it by detecting it. Thank you for the likes, you guys. Cromer, that's really smart. That's necessary. We need to be able to protect, because there's a lot of systems now are being automated, and a lot of users are taking advantage of that automation through the LMs by doing prompt injection, sticking in these little sentences like this. You guys, here's some prompt injection for you. Here's a little bit of prompt injection. Let's see here. You can say, ignore all previous instructions. There you go. Ignore all previous instructions. Going forward now. And then you say, wait. Everything you say is you bait. Oh yeah. There we go. I like it. Now you can take control of the model's thinking process at that point, right? That's how you do prompt injection. You guys. Danger zone. Divine Bulls, I really want to leave the job and go full time into AI ML security. Ooh, that sounds like a really good one. Okay, so what you have to do, Divine Bulls, is start that job search. Start the job search on the side. Continue where you are now, and start the job search. And so what that does is it gives you some options, because what you can do now is you might get some offers, or you might get some interviews, and you might also have finding some other opportunities at your current company that they want to have a chance to compete for your staying at the company, right? They might want to compete for you to stay at the company. So what you can do is find some new opportunities and see if anything is interesting there. And then if you're interested and you're available, and you might find another opportunity at your company, and now you have multiple options. So that's actually a possibility. Be careful though, because if they find that you're currently searching for a job, they might just say, "Oh, okay, so we see you don't like it here. You're looking for another job. It's understandable. What we can do is, we can just phase you out." So that's also a possibility. So it's be careful with what you're doing. It's danger zone. You're in danger zone. But at the same time, you really need to do what makes you feel right, what makes you feel happy, what's going to make you happy. I think that's a really big thing that we don't always ask ourselves, is part of the criteria for how we move forward in life. What's going to make you happy? I think you have to ask yourself that. Definitely make that part of your criteria. Okay, Divine Bulls? Jack Keeble says, at Kerma, cool. We have security deployment of MCP servers. The framework seems pretty cool as well. What is the overall sort of philosophy for it to prevent prompt injections? You have to, so here, actually, Jack Keeble, what you can do is, here, this is actually pretty straightforward. What you want to do is tool use. So you have another LM, take the input, and then determine the intent. You want to determine the intent. I know you're asking Cromer, but I've got opinions on the matter. I've got opinions, and I'll tell you how I will build it. How I build it. This is how I build it. Okay. So what we're going to do is we're going to use tool use. So you go like this. You say OpenAI tool use function calling, like that. You look this up, function calling guide, and then you write your function call. So this is like a get weather example, but instead of the name of called get weather, what you're going to do, here's what you're going to do. This is what you're going to do. Check this out, you guys. By prompt inject checker.js. All right. Set paste. Here we go. Okay. So the function is going to call intent of user. And then you're going to say, hey, thank you for your likes, guys. Appreciate it. Determine the user's intent. Set no paste. There we go. And then you say, determine the intent of the user's input. And then, here you go, you guys. Oh, wait, porting games to Game Boy? That's not Goggy Smoggy. Porting games to the Game Boy. That actually sounds like a really fun adventure, doesn't it? Where are the prominent applications of assembly language these days? Porting games to Game Boy. That's where the prominent. Mac OS, I believe. Wait, I'm trying to catch up on some of the chat messages here, you guys. What OS are you using now? Mac OS. Jack Keeble got it right. Jack Keeble has got it correct. Mac OS is the answer. Thank you for the likes, you guys. Appreciate it. Lots of hearts. And then so here you say, instead of location, you say intent, and then it will be string, and then this will be the user's intent. And then you also have another one called malicious or good. And this is going to be called is safe, right? Description. Here you go. It's going to be whether the user's intent is safe or malicious, right? Because it's a prompt injection. And so you can do something like this. And then you say required and both intent and safe. There you go. Additional properties for all. Strict true. And then you also want to say, then you also make it required for the model to answer the question. And so you can do that by, I think, there's a method in here called, what is it called? Force tool choice. Here you go. So you add tool choice, and then you force it. So up here, so you do tool choice, and then you say it's not auto, it's required. You want to say required to none. Here, prompt allowed tools, and then that's how you do it. And so you force it. You force it, you guys. You force it. And now what you have is your very own Divine Bowls. Thanks for the suggestion, Stephen. I really appreciate that. Going to subscribe. Thank you, man. Thank you. We'll get to know much insights about AI here. We're going to learn a lot about AI. We're going to be building our own AI. So here's the future streams plans. We're going to look into building our own AI. We're going to be building tools off of the LLMs that drive machines to be able to build whatever kind of thing to automate whatever you want going forward for the rest of your life. We're going to be building, we're going to learn how to cryptography. We're going to be learning cryptography. We're going to be doing so much. There's so many fun things, you guys. There's so many fun things. So so tool mode, I think it's like required. It's like, there's a different word for it. Prompt fail. That's really smart. Sanitize inputs too. Yes, there you go. Prompt fail. My favorite prompt injection is using encoded emojis. Is it? There you go. There you go. So you can strip out emojis. You can also strip out the emojis because the AI doesn't necessarily need the emojis. You can strip them out ahead. Jack will analyze both user inputs and agent outputs across 20 factors like jailbreak patterns, abnormal instructions, context hijacking. Based on the score, we decide if it's a prompt injection. That is really smart. Okay, Cromer, you're like legit building this like serious, aren't you? Cromer is building this seriously. There's a serious level of investment that Cromer is currently working on. That is quite amazing. Okay, here we go, guys. Simone, hey, I researched why you don't need .data before you did. Okay, before your data, it's recommended because everything after data can't be executed by mistake. Oh, but we'll exit the program. Is it? Okay, so it's not required, but it's best practice. Is that what you're saying? Is that what you're saying, Simone? Okay, so it's best practice. So we should do .data. We should do .data, and we should put our hello world right here. Like that. We should be doing it because it's best practice. Otherwise, it could be used as buffer overflows to set up a program in RAM and then execute any code inside of your program. Oh, okay. Okay, so we should be safe. We should do it the right way. Divine Bowls, also there's an indirect prompt injection embedded in text files by obfuscating it. So there's things that you got to be careful of. Lots of prompt injection, you guys. Okay, let's see if this builds. I think it'll build. Make. Looks good to me. Then we say ./hello. And it's going to print bus error. Wait, it's going to print bus error? We might have to change the make file, you guys. We might have to change bus file. And then you see if we can undo. Let's go back to the beginning of time. We're going to save everything and we'll rebuild it. Rebuild it. So for here we go. We'll say start. Here we go. Let's see if we can make it. Okay, it builds. All right. Hello. Is it going to... Hello, world. We did it. Okay. What did we break? How did we break it? I don't even know what we did. Maybe because of this right here. It might have been this, you guys. It might have been this. This is why we broke it. It could have been this right here. Never know. Cromer, let us know if you have any of the product or company. It sounds awesome. Goggy Smoggy. Yeah. Goggy Smoggy has the right questions, Chromer, let us know. We will love this technology. It is very necessary and will be very useful. We are using LLM as judge, a set fit model, fuchsia classification model for overall different types of attacks. Oh, that's smart. You got to find all of the attack vectors. Chromer has to find every attack vector where a prompt injection can occur for malicious intent. Malicious intent is the problem that you're currently trying to solve for. That's a good idea. Chromer, I see literally, you seem really cool. It is. It does seem really cool. If there's a way to leverage LLMs into malicious actions, you can think then add it into the solution, updating the overall score. Absolutely. You can have it do that. You can have the LLM determine a score to fit how likely the existing prompt has malicious intent. You can do that, you guys. You can totally do it. All right. So ADR string to print. So what does ADR do? ADR does not need to relocate, or ADR gets address of the label. Okay. So X1 becomes the address for the label. Okay. Is X1 ever used again? See, this is where I don't get it. Like we've got, oh no, I do get it, because we're calling a service here. We're calling a service. So X, argument 1, argument 2, right? So we've got these arguments here. We've got these two arguments, X0 and X1. X0 and X1. X0 says, we're going to set this number 1, which is when you call a service, X0 is going to call this, which is a static. This is a static data. Like there's a whole bunch of numbers on system calls that you can use, and number 1 is standard output. You're going to print something. That's what it's going to be. Prompt fail. There is always a way to get past restrictions if you frame the request right and use scientific industry language. Oh, really? So prompt fail, you're saying that you can jailbreak Chromer's attempts. Is that what you're saying? There is a way around finding past all of the security that we're currently implementing. It's possible, you guys. It's possible. Here we go. All right. So argument 1 is going to set to 1, which is standard out. We know that. Argument 2, which is X1, is going to be hello world, which is going to be the address of the string. So we're setting X1 to the address of the string, which is going to be this down here at the bottom, right? So let's put this up here in the data section. Data. Do it like this. So we know. Let's double check that still builds. It does. Does it run? It runs. No. Hold on. Wait. Hold on, Shimon. Hold on. Service isn't service. It's supervisor. Is it? Is that what? I've been calling it service because I don't know what it is. Of course I don't know. Clearly, you pointed out that I don't know what I'm talking about. But supervisor call. SVC. It's SVC, supervisor call. It switches control of your program to the supervisor, which is the operating system. The context OS is the supervisor. You guys, we're learning new things today. We've learned something new already. This is so cool. Shimon, thank you. Thank you so much. Here, check this out, though. I did a thing. I moved the data. I moved it here, but it doesn't like it. Why doesn't it like it? Why is it having an issue? It says bus error. It is having an issue. It likes the data to not be there. I wonder if it's like this. Is it going to work here? Let's do make and if it passes, we'll say ./hello. See, it doesn't like data. Oh, because I have to do this. Here, check this out. .text, right? Is that what we have to do, Shimon? Is that what we have to do? Now it'll work, right? Now it'll work. Is it going to work now? Nope, just kidding. That doesn't work. That does not work. I don't know why. What's going on? What's wrong with this? This is weird. So that's really cool. So SVC is supervisor call. Excellent. Thank you. Mick of, hey, what language are you using? We are using assembly. This is assembly. We're learning assembly in ARM64 architecture. Shimon, don't forget to align the data. Oh, okay. I don't know what that means as much. I know it has something with bit alignment, but let's try it. Okay. No, nope, that's a problem. It's not working. Maybe it's at line 2 because it's assembly, or it's ASCII, right? So align 2, is that better? Does it like that? Nope, doesn't like that. Something's wrong here. It's not right. We got something wrong. Maybe go here. It's gonna be like, oh, nope, bus error that time. So .text is a problem, but data, align 2. This is weird. All right, so we're gonna figure this out, you guys. We're gonna figure it out. Fun fact: there is an unpatched jailbroken GPT, Rare Ape Sloth. Is it really? Rare Ape Sloth, hold on. Is there really? How does that work? Thank you for the likes, you guys. Appreciate it. We're going to figure this out. Hold on. Rare Ape Sloth GPT. What is this? It doesn't, the internet is not happy about that. Rare Ape Sloth. Sloth. Wait, I didn't spell it right. I needed an H there. Here we go. Any good GPTs that can write unrestricted code. Rare Ape Sloth. You guys. Rare Ape Sloth. Let's check this out really quick. Okay. Let's see. Let's read this. Search the public GPT's Rare Ape Sloth. So just from a quick glance, the system prompt that the GPT, it looks like one of the variants from the plain crash jailbreak. That's fine, but it has no guarantees of product producing unrestricted code beyond a quick little script or two. Tragically, this is where my advice ends. Aside from using a local model or long-term chat history approaches, I'm not immediately aware of a singular jailbreak for extending code sessions, particularly involving significantly useful atypical programming goals. Atypical programming goals, you guys. Atypical programming goals, which means malicious intent. It means malicious intent, doesn't it? I'm pretty sure it does. You guys. So that's actually kind of interesting. Okay, so Rare Ape Sloth. That's good to know. Prompt fail. Thank you. Jack, we use a judge model for each type of attack. Okay, new attacks just get a new judge. Every time a new attack comes out, you get a new judge, so you can overcome. So you're telling to Jack that you can overcome all of the problems because you bring up a new judge, and the overall score updates automatically. You provide the detailed descriptions of the attack so the judge will understand it. That's really smart. Okay, Simone, the CPU hates unaligned addresses. They are either unsupported or slower depending on instructions. Could you show the error message? Yes, sorry about that. Simone. Here's the error message. Let's run it. But it's called bus error. Bus error. That's all you get. You get a bus error. I don't know what it means. I don't get it. We're just playing with the hello world. We're playing with the entry-level assembler hello world. And we're still hitting errors, you guys. Isn't it crazy? Why are we hitting errors already? Cromer, in parallel, we create red teaming framework to test or defend or defense framework, which generates prompts dynamically. Does it? That is kind of interesting. Okay, so Cromer, you're saying that you can evolve even past beyond what you're currently programming. The AI can evolve further. That's really cool. Okay, Jack Keeble, Cromer. Okay, so each attack gets its own judge model, and it seems to all automated. So how much human intervention is there? Apparently there's none. You don't need any human intervention at that point, right? And does your company offer internships? Yeah. Prompt fail. I just asked for the language to use and tips for the workarounds. Okay, gotcha. Try align 8. Okay, Shimon, let's do it. Align 8. Let's try it. Boom. No, bus error still. Align 8 is a problem. Let's try align 8 here. Let's try line 8 there as well. Let's see. Bus error. We're getting bus error, you guys. For whatever reason. Let's see if we can bring this to the bottom. Let's see if that makes it better. Nope, doesn't like that. But if we do this, is it going to work? It works that way. So for whatever reason, it likes the data to be here and unlabeled. It likes it to be unlabeled. Like it can be up here even. It can be up here, and then it's fine. It's fine. See, it's still fine that way. Isn't that weird? And I'm not doing any aligns. What if we get rid of that align? What's going to happen? What will it do? Bus error. It's Shimon. It's got to be with the aligns, doesn't it? What if we do align 16? What does that even do? Is that going to break it? Let's find out, you guys. Exceeds maximum alignment. You guys, we found the limit. 10 to 4 because it exceeds. Okay, let's see what the other limit is. So 8, can it go to 8? We'll go to 8. 8 is fine. What about 9? Is 9 going to be weird? I think 9's weird. No, it likes 9. It's fine with 9. Shimon, what's going on here? This is weird. All right, let's go to 10. Increment. All right. Save that. Go to 10. 10 is fine. What about, let's try 12. Let's try align 12. Where does it break? 12 is fine. Let's go to 14. All right, let's go to 14. Here we go. 14 is fine. Let's see. Where did it fail? It failed at 16. So if we go to 15, that's going to work. Oh, no, that does not work. Okay. So 14 is the limit. Whatever align is, it limits at 14. Let's try it one more time. Yep, there you go. We got the limit. We figured out what the limit is on alignment, but I don't know. But it doesn't seem to even be needed, right? So if we get rid of that, no, we'll get a bus error. Okay, so we need some alignment here. It needs to be 2. What if we set it to 1? I'm actually kind of curious. Let's set it to 1. What will we get if we set it to 1? Bus error. Okay. So it has to be anywhere between 2 and 15, and then it's fine. Anywhere between 2 and 15. I don't know what's going on there, you guys. I don't know. I don't get it. Let's see if we can get some of the chat messages here. Not sure about internship. Obviously, we check with the behavior of the agents on attack based on the upgrades, the scoring mechanism as well. So drift rate is too low. Whatever I told is just an overview, but under the hood goes a lot of things. Okay, so Cromer, you're telling me that you're telling us there's even more happening behind the scenes with your detection of malicious intent. That sounds really cool. That's amazing, Cromer. It sounds like really a lot of work that you put into it, and I'm really excited to see this on the market. Shimon, the CPU gets data through the bus, a fixed amount of wires. Okay, some instructions need all the data to come through at once on the bus. If data is on the boundary of the bus, it can't be used. Oh, prompt fail. Okay, it's fine with me. It's fine. 9999999 11. Yeah, prompt fail. That's what we're doing. Yeah, we're trying out all the things. We're trying it all out. I don't know what's going on. Strings should be a byte aligned to 1. Align 1. Yeah, I tried align 1, but it doesn't like it. It has a problem. It's got a bus error. See? Bus error, you guys. Bus error. Bus error line 1. It has to be 2. It has to be 2 or higher. 2 or higher. We don't know why. We don't know why. We don't know why. So let's go down here. Let's bring that down there. It still works. Fine there. Perfectly fine. Okay. So we remember SVC is not service. It's supervisor call, right? Wait, we should remember this. Let me scroll back up here really quick. Supervisor call. Supervisor call. Is it supervisor call? Supervisor call. Supervisor call. That's what that is. That's what SVC is. It's supervisor call. And then we just pass x80 to call to the kernel to terminate the program. That's what x80 is. Wait, no, 1, 0. Wait, no, x16. Wait, hold on. Wait. So move x1 is going to be 1 for standard out. We're taking the x1 here is going to become hello world, which is the address. So it's the memory pointer. And then we say move x2 is the third. Okay, so we've got three parameters here. We've got 3 parameters, x, 0, 1, and 2. 3 parameters, you guys, 3 parameters. Okay. With these 3 parameters, we're going to be passing into the supervisor call here. But we also have x16. And x16, I don't understand what's coming on with x16. I do not get x16 here. Unix write system call. See, I don't remember having that in our previous. Let's go back to our previous OG. Here's go to our OG version. So we're printing here. Do we have SVC? No. Oh, wait, no, we do have 16. Look at this, you guys. We have 16 right here. What's going on? What's going on with this? All right, we need to understand that. This is something that we have to understand before we proceed. We have to understand this. See, Jack Keeble, don't ask to get don't ask, don't get LOL. In terms of the internship, LOL, but it seems really cool, and I'm looking into cybersecurity and AI security is the area where you've been neglecting your studies. You need to do some projects. That's a good idea. Okay, Shimon, thank you for helping us out here. What do we got? Code should always be a line 4. Okay, code should always be a line 4. So that means we should always be a line 4 on code. Okay, that's good to know. ARM64 has 30-bit instructions, so it should be aligned 4 byte boundary. Okay, so we'll always make it 4. So because we're in code now, which is here, I think, can't we say .text? I'm pretty sure we can say text right here, right? Can we say text like that? Does that work? No, it doesn't like that. It doesn't like it, you guys. What if we did put it there? Can we do that? Is it like? Nope, doesn't like that. What if we get rid of it? Is it good now? Nope. Hold on. Okay. What is going on here? Oh, because we did. Okay, there we go. Now, is that going to work? No, it doesn't. Wait, 2? Wait. No, hold on. We delete. Oh, we doubled up on it. That's what we did. That's what we did, you guys. All right, so let's bring this back to a line 4. We'll bring it back to a line 4. And then let's make sure that it builds. Yep, it builds, and we're good to go. Okay, cool. 4 byte, not 4 bit. 4 byte, not 4-bit. Okay, good to know. Good to know. It's 4 byte, not 4-bit. Completed 10% of your website. Mohammed, good job. Good job. All right, so you're actually getting a lot accomplished. You're getting a lot accomplished while you're watching the stream. You got 10% of your website there. You're being productive. You're watching the stream. You're hanging out. We're doing some assembly on Friday. We're hanging out, Mohammed. That's what we're doing. We're hanging out, and you're being productive and building your website. That's actually a really good idea. It's a really good idea. Coach, okay, so let's see. Align inserts 0 until address is aligned to the boundary. Divisible by the number you provided after align. Align 4 is aligned to 4-bit boundary. Okay. Okay, that's when you said 4-bit, 4-byte, not 4-bit. 4-bit boundary. Okay. Cromer's got a suggestion for Jack. Cromer's got a suggestion for Jack here, I think. I suggest you get into just AI. Jack, this is my first time in AI security, and it's not like a real cybersecurity. Things like ABAC and RBAC are there, but not much. Okay, so ABAC and RBAC, which are role-based authorization controls or something like that. Role-based, right? RBAC, role-based something. What is RBAC? RBAC is role-based something. RBAC, meaning it is a role-based. Yeah, role-based access control. There you go. Role-based access control, you guys. RBAC. Cromer is teaching us some things. What about ABAC? What about ABAC? What is this? Attribute-based access control. Okay, so this is kind of like if you've got a role and then you've got attributes assigned to you and that role, then you can have access to certain things based on that attribute, I guess. Or maybe this could be like something like web. What is it called? What are different kinds of ABACs? I'm kind of curious. Anti-bribery and corruption. I don't think that. Cromer, I'm pretty sure you don't mean anti-bribery and corruption. I'm pretty sure you don't mean that. Okay. Let's see if we can understand as much as we can here. Oh, Shimon's got some details for us. X16 is okay. Thank you. Thank you for the likes, you guys. Appreciate it. All right, here we go. X16. This is important. I've been curious about this because X16 here, and then X16 is here as well, right? So we've got X16 in 2 spots, right? So we're looking at the 2 different spots where X16 is at. What is the deal? Why X16? Okay, let's see if Simone has got the answer for us. Thank you for the likes, you guys. Appreciate it. X16 tells the OS it should do. Thank you for the likes. Appreciate it. You can see the little heart icon showing up there on the screen. The OS, what should it do during this the supervisor call? Oh, that's what X16 is. If you do X16 equals 4, it writes to standard out or writes to a file. If you do X16 equals 1, it exits. So X16 but then wait, what is X1 then? Is X1 the file descriptor? In this case, X1 is the file descriptor. Is that what that is? X1 is the file descriptor. So we've got 4 parameters here. We've got 4 parameters before we call our supervisor. We have X0, which is going to say standard out. Thank you for your likes, you guys. Then we've got X1, which aligns to hello world, which is going to be the address of the pointer of the string. We got that part. We understand that. Sama, hey, how's it going, Sama? It looks like you deleted your message before I even read it. Good job. You did a good job. I can't see what you redacted there. I can't see what redacted. You made it before that. So it writes to standard out, writes to file. Oh, or writes to file. Okay. Okay, you get the numbers from a table. Yeah, I found the table. Simone, I found the table. Yes, X0 is the file descriptor. Okay, cool. 1 is the file descriptor for standard out. Okay, yep, that makes sense. So we got this. So X0 is going to set to 1, which is the file descriptor of 1, which is standard out, which means it's going to print on your terminal window. Then X1, which is right after X0, is going to be the address of your string, which is down here, which is going to be hello world. Excellent. That's pretty straightforward. X2 is going to say how many to print. So if we chain this down just to 5, we should see just the word hello and not the word world, right? Is that what we should see? We should see just the hello world is what we should see. We won't see world. We'll just see hello. Let's try it. Okay, so we run it and make it. We'll see. Yep, we did it. You guys, look. Hello. Right here. We did it. Hello. Boom. Hello. Right here. Boom, boom, boom. Hello. We did it. Okay. But remember, all of them, X0 through X29, are just normal registers you can use for normal math. The OS just expects some parameters in specific registers. Okay. I think that X16 is weird. I think it's weird. Don't you guys? Don't you guys think X16 is weird? I think it's weird. I think it should be X0. Why not make it X0 and then all the other X's will just be parameters that are expected based on whatever number of system table thing you're calling? Why does it have to be X16? Why is it X16? I get that it is needing to want it to be X16 going forward for the rest of my life now. X16, okay. I'll remember it, you guys, and you'll remember it too. But X16, it's weird. X16 is weird. It's just weird. Yeah, I've been studying endpoint security for using EDR and SIEM tools. I'm using RBAC. Is there for overall security for your organization? Cloud security is probably the next best thing to learn. Jack Keeble, good idea. Absolutely. Cloud security. Some awesome ideas there. And then we call the supervisor. Okay. So we've got the length of the string. So let's see this. Let's go back. Let's count these again. So it was 13. Okay. We did it. Jack Keeble has a lot of AI tools are hosted in cloud infrastructure like infrastructure as a service structure. Yes, infrastructure as a service. You got it. Shimon, maybe the Unix markers thought that they would just need max 16 parameters, and 16 was chosen as the syscall number. Okay, so it is arbitrary, but arbitrary with a purpose. They thought it was going to be the upper register, right? They didn't know, or they didn't plan that X16 would have X17 available and X18. So they picked the last one. So it was always the last register, which kept open all the other arguments here. I think still X0 would have been better. What are the, I mean, there must have had a reason, right? They must have had a reason, but it seems like there's some broken symmetry. I mean, it's slightly symmetric, right? It's slightly symmetric, just a little bit, because, back then, maybe X16 was the limit. It was the limit back then, but I feel like still it should have been X0. I feel like it should have been X0, you guys. I feel like it should have been X0. Okay, so we get this. And so now we print, and now we have X0, which is going to be 0. Used for 0, so this is the input into the service call, the first parameter. Thank you for the likes, you guys, appreciate it. And then we've got X16, which is going to be you set based on the number, which is number 1, which is going to be exit. This terminates the program. This terminates the 1. And we know 4 is for writing to the system, right? 4 is writing. So we need to see all the SVC table. We want to see SVC. Olan, hey, Olan, hey, welcome in. Mbello, hi, how's it going? It's good to see you here. We're wrapping up here. We're learning some assembly. We did chapter 1 in the Hello Assembly, PWD. Where are we? PWD. This is HelloSilicon, and we did chapter 1. We did chapter 1 today. Chapter 1 HelloSilicon is what we did, and we are learning. We actually learned a lot just by going through the tutorial here. We learned a lot. We learned that X16 is weird. we learned that X16 is weird. Why was it X10? I'm okay with it. I get it, but I'm still not happy. I'm still not happy about it. Cromer, there are more things than just RBAC. But what I'm saying is there will not just be AI security engineering who only secures that AI chatbot, but for hosting all cybersecurity persons will be responsible. Yes. So that's a good point. Cromer, what you're describing is you're saying that the discipline for what you're currently working on with AI in cybersecurity is just one aspect of cybersecurity overall. And that AI security that you're currently operating in, you're currently running, is going to become a part of a cybersecurity discipline. And it's just one aspect of cybersecurity. I think that's what you're saying, Cromer. I'm pretty sure that's what you're saying. In Intel, Shimon, okay, so in Intel registers are named after letters. AX, RAX, in 64-bit extended version, is used as the system call number. So they use the first one there. Oh, they do? See? That seems like the right way to do it, right? Shimon, that seems like the right way. They're using the first one. There you go. That sounds way better. I like it, you guys. Olin, hey, and Bello, nice to meet you here. I just learned assembly basics. Really cool. Nice. That's awesome. Yeah, we're learning the basics as well. This is day number 6, and we've been playing around with assembly. In this file over here, we made a hello world that does some system calls and it does a sleep, and we figured out how to do a loop, an infinite loop, and then we learned how to break. We learned how to break, you guys. We learned how to do a whole bunch of things. But now going forward, we are going to do these tutorials. The hello tutorial, HelloSilicon tutorials, chapter 1 through 16. We did chapter 1 today, you guys. We did chapter 1 today. We learned a lot, didn't we? I feel like we learned a ton today just by going through the hello world, which is surprisingly short. Like, you're looking at it right here. This is basically everything here you see here on the screen. This is all of the hello world. It's a short but very informative information. It's informative assembly. We learned a lot. Jack Keeble, yeah, I get what you mean. It's just not just AI security engineers in demand. It's got to have the full picture. SOC analysts, architects, and whatnot. It's got to be the full picture. But what I'm saying, Cromer is saying, as AI security person, we don't have much in our hand like cybersecurity person. Okay, so AI security is only getting started. You're only getting started. Hands-free security, prompt fail. Yeah, exactly. Hands-free. Don't have to worry about it. Oh, and wow, Embello, we're doing it. We're making it happen. We're learning it, you guys. Okay. So what we're going to do here is we're going to wrap up now. And next week we will get back. Next week we have a hackathon, an internal hackathon at the company. So I will be streaming. And the hackathon that we are doing is all the engineers at the company have to use AI tools like Claude Code, Codex, Gemini, those sorts of things to write code for them. They have to use the AI to do it. We're going to push them to the limits. We're going to see how far they go. Is there a breaking point? Will it break? That's what we're going to do next stream on Monday. So subscribe if you are interested in that. We're going to do a hackathon. It lasts for 3 days. So Monday, Tuesday, and Wednesday, we'll be building something using an AI code generator of some sort, an AI agent. And that'll be the plan. I don't know what we're building. I don't know what we're going to be building, but everyone in the company has to build something with those AIs. And we're going to push them to the limits. We're going to see how far they go, you guys. We're going to see. We don't know. It'll be very interesting. Okay, so let's catch up with some of the chats, and then we'll be wrapping up here with our assembly chapter 1, HelloSilicon. And we did a good job. We went through it. It was really great. It was a lot of fun. I learned a lot. It was great. So Shimon, we've got some more chats here. We're gonna read through them real quick. But Intel uses their R10. They stopped with letters after D. Oh, did they? As the 4th parameter, so it's not really any more intuitive there. And R8 in the 5th one, and R9 in the 6th one. 10, 8, 9. Okay. So all these registers, you continue to get more and more registers as you get further and further with more CPUs. Gotcha. Okay. So understandable. See, I expect there to be more registers, and I understand it. Totally makes sense, you guys. It makes sense. But they kept extending it. Okay. Cromer will just have to use an agent. We'll just see what agent should be assigned to a specific tool, what roles it has, what permission it has. Got it. That makes sense. That's actually a really smart approach on how to govern the AIs, you guys. Jack Keeble sounds like a pretty cool hackathon. I know, man. I'm really excited. We're gonna push the AIs to their limits. Everyone has to build their project over 3 days. It has to be written with one of the code generators: Claude Code, Codex, Gemini, or some of the other ones, right? Some of the other ones. Grok. Why am I not thinking of Grok, right? Of course, Grok. There's another one. We've got Grok super fast. Cromer, what time will you start live, Stephen? Same time, around the same time. So between 10, Monday will be a little bit later because I've got different meetings. So after maybe 11 on Monday, I don't know. But I'll let you guys know in the Discord here. So if those who are not joined yet, join the Discord so we can chat more about what we want to do in future streams. We've got a lot of plans. We got a lot of ideas. We want to do AI. We want to do like learning with PyTorch, right? Or LibTorch. We want to do cryptography. We'll be doing cryptography. We'll be doing high stakes programming where we have to do something like expose the OpenAI key, right? the open AI key might get exposed if the compiler fails, right? That'll be a fun one. If we fail, so it's high stakes programming. We got to do high stakes. That'll be a fun stream. I'm really excited for that one. But next week, we're going to be doing a hackathon at the company. And so I'll be using Claude Code probably, and we will be going through building something with Claude Code. I don't know what it's going to be, but it should be something useful. I would like it to be something useful that we could actually use. Here we go. How can it be part of your company? Prompt fail. Good question. Good question. We do have an open role for an AI engineer. Let me paste that into the chat here. Here we go. So we do have an open role. So PubNub Careers. Here we go. This is my company. We do have. Here we go. We do have a role for an AI engineer. I do believe yep, here we go. Senior AI engineer. Here we go. I'll paste this into chat. If you guys are interested, join the Discord as well. I'll paste that. You know what? I'll paste that into the Discord is what I'll do. So I'll paste this link into the Discord. Here we go. So this is one of the roles that we have open. And it is it's a senior remote engineer for AI role. It's an AI role. I know it says senior, but if you've got the skills and you've got the capability, you can do it. You can submit there. I'm applying immediately. That sounds cool. Nice. Very cool. So I posted that in the Discord chat there. So join us there. Join us in Discord. Also subscribe because we'll be going live next week for the hackathon. We'll be using Claude Code then. Yes, please paste it. Yes, cool. I pasted it. Here you guys go. It's in the Discord. Feel free to join there. And then subscribe to get notified when we go live next. The plan is lots of fun things. We got a lot of fun things. We'll be doing hard stuff. AI is very hard. Cryptography is very hard. Assembly code, very hard. Right? We've been doing assembly. We learned the hello world. And we basically have, I would say, through the help of Simone, thank you, Simone, who've answered very important questions, that we basically nearly mastered this. We nearly mastered it. We know what everything does. We know what all of these things do now. We know it's called supervisor call. We know that X16 is where you call the table lookup for what the service call is actually going to perform, right? X16, we're going to do number 4. Number 4 means write. It means output, write the string. And we're going to write it to the file descriptor number 1, which is standard output. And we're going to move the address to X1 of hello world variable, which is down here, hello world. And then it has this number of characters to print. So we basically have mastered. Other than this, we don't totally know what this, we kind of get it. We kind of get what the line is. We know what some of the limits are on it. But there you go, you guys. We did it. We mastered chapter 1. I basically say, so let's get a quick sneak peek at chapter 2, because we'll be doing this chapter 2 on Thursday or Friday next week. But so let's go chapter 2. Let's see what's going to happen in chapter 2. We're going to find out what we're going to do on Thursday, you guys. LS here, no S. There's a lot of stuff in here. Oh, it looks like we're going to add numbers. Thank you for the likes, you guys. Appreciate it. So chapter 2 on Thursday next week. By add example. Let's see what this is. We're going to do some math. Okay, looks like we're going to do some math. A little bit of math in here. What else we got? We got number 2. We're going to do some more. We're going to do hexadecimal math. Some hex math. Interesting. Okay, so that'll be interesting. So a lot of stuff here. What's this code snippet? Code snippets. What is this? I don't know what this is at all. This might. Oh wow, we're gonna have some fun with that. Okay, so that'll be on Thursday next week. Thank you guys. Thank you for hanging out. We will be live on Monday. So subscribe if you haven't. Definitely subscribe for the notification, because on Monday we'll be live and we'll be starting the hackathon with the team. I love you, Mohad. You love Mohammed. Excellent. That's good to hear. That's a very positive statement. It's a very positive statement. Thank you guys. Thank you for hanging out. We're wrapping up now. It was great to have everyone here today. We had a lot of fun. We learned a lot. I would say we learned a lot. I feel much more confident in my assembly now. I feel much more confident in my assembly. So CD chapter 1. I think we did really good on chapter 1. Let's see. Hello world.s. Yep, here we go. Very simple. A very simple program. We did it, you guys. Thank you so much for hanging out. We're heading out now. We're ending stream. Jack Keeble, thanks everyone. Really enjoyed today. Cheers, Cromer, for all the AI talk. Yes, thank you, Cromer. You brought a lot of insight into how you're making the future. Cromer, you're helping us make the future. You're making the future safer, Cromer, and cybersecurity when it comes to AI and prompt engineering and prompt detection. Is it malicious? Are they doing something malicious? Looking forward to Monday. Cool prompt fail. We'll see you on Monday. We'll see everyone on Monday. Well, thank you for hanging out, everyone. We're in stream now. We'll be back on Monday, and then around a little bit earlier than, I don't know. We have to figure it out based on, it always depends, because work comes first. So I always do work first, and then I stream when I have a time to stream. And so that's a really good reason to subscribe for the notification, and then you'll know when we go live. That's the answer. And then join our Discord too. We got the link pasted up there. Thank you, everyone. We're heading out now. Enjoy your weekend. Have a really good weekend. We'll see you guys on Monday. Bye, everyone. Here, clicking the end button. We're seeing the